Hello and welcome back to the video lecture series for Introduction to the Art of Programming Using Scala. This is the last video in the chapter on arrays and lists. This last one will cover new material. And in this I want to talk about two more methods that exist for both arrays and lists. And these are called fill and tabulate. Now when we first learned about arrays and lists, we talked about how you can make them. It is something that you kind of have to start off being able to do. In this video, we're going to learn about some alternate ways of making arrays and lists. And in fact, these are probably the ones that you're going to use the most. So let's look at the go back and review the methods for constructing them. So we talked about how you can make short arrays or short lists using a syntax like that. If we were to replace array with list, we would get a list instead. In the case of an array, we could also make them by using new and telling it how many of the things we wanted. So we could make an array of int and say it has 100 values. And they would all start off in the default. So if it's a numeric value, the default is 0. And that would allow us to get a large array of things. In the case of lists, we saw that in addition to using this syntax, we could also use the cons operator and build lists off of nil. And so we could get these results, and by consing things on, for example, with recursive functions, we could build larger lists. There is no version of this for lists because the lists are immutable. Having a really big list of all zeros would be kind of useless. Having a really big arrays of all zeros is fine because you can mutate them. However, this syntax right here in particular is something that you'll typically want to avoid. And the main reason you want to avoid it is because of what happens if you don't do a numeric type, you do something like a string, what we call a reference type. And now you can see that I have a big array full of null. And when we talked about the passing and we looked at how variables are little boxes that point to things, basically what null means is this is a box that points to nothing. Okay, it doesn't point to anything yet. And the problem is if you try to do something with it. So for example, this is a string. So I should be able to, this is an array of string. So I should be able to pull off the first element and ask how long it is. That doesn't work. Okay, it gives us an error, and it gives us an error here because it's something called a null pointer exception, because there is no string that this points to. It doesn't point to anything. So it turns out these null pointer exceptions are really common. For example, if you're programming in Java, they're one of the most common errors that people run into. They're far less common in Scala, and one of the ways that you can prevent yourself from running into them is to not use the new syntax for arrays. Instead, you should use fill or tabulate. So what do these methods look like? So first off, let's we'll reuse that same variable name. Make a big array, and we're going to call fill. And since I'm making an array, I'm going to say array.fill. Okay. And this calls the fill method technically on the array companion object. This is inside of the main array. I want to say type. It's not technically correct, but it'll work for now. Now, one thing about fill is, and this is also true for tabulate, is that they introduce a new style of syntax that we haven't seen before. They are what are called curried functions or curried methods. And a curried method takes two or more separate argument lists. So in the case of fill, we don't give it how many items, comma, what to fill the values. We separate them as two separate argument lists. So for example, if I wanted an array that had 100 fives in it, I could do that. Yeah. And so this syntax here where you have separate argument lists is what's called a curried curried arguments. You actually can, if we had a function, so let's say that g takes two values, an x and a y, and all I want this to be is to give you back the value of x times y. Okay. When I call this function, I pass it in two separate things. Now, the thing about currying is that you can call this and pass only one, and when it's defined with def, we have to put an underscore here so that Scala knows that we really meant to call this with only one of the arguments. This, when you call g of 2, so first off, g takes a double, and then it takes another double, and it gives you back a double. The type there is double, rocket, double, rocket, double. There are two rockets in there because the first function gives you back another function. So notice that this, we'll give it a name. Okay. This gives us back a function that only takes one argument. So if I call plus 2 on 3, or oops, I shouldn't call it plus 2, I did multiplication. Should have called it times 2. Let's go ahead. Okay, we get this. So the advantage of currying is that you can actually separate out the arguments and pass them separately. You can't do that if it's a single argument list. Okay, when it's a single argument list, you have to pass all of them at the same time. There can be some other advantages that deal with type inference and how Scala figures out the types of things, and that's one of the big benefits when it comes to using fill. Now, another thing about fill, not only is it curried, but it utilizes what we talked about in the last video of these values are passed by name. At least the second one is. The first one is just a straight up int. But the second one is a by name argument of whatever type that it is that you want back. So when I passed it a 5, well, it kept evaluating 5 and always got back the same value. But we can show that this is by name by passing in math.random, and now we get 100 random values. And you can tell that this was by name, as we saw in the last video, because if this had been by value, this would have been called once, and we would have had 100 of the same value. But it's not. With fill, it's passed by name, and so these things happen over and over again. So fill has a close partner called tabulate. I guess one thing that's worth pointing out here, as opposed to the new syntax, when I called new, I said that new array, and then I gave it the type, and I told it how many to create. For fill, you note that I did not specify a type here. And that is part of the advantage of using fill, is that we get to let Scala's type inference engine figure out the type for us. In this case, because math.random gives you back a double, that's exactly what we got. But I could do something like this. I could take math.random times 100.toInt, and now I would get an array of ints instead. Okay, so the fill figures out the types for you, and it allows you to initialize them to something other than default value. And one of the big advantages of this is that you avoid nulls. The only way that you can call fill and get a bunch of nulls is if you happen to put null here. Well, if you do that, then you get what you deserve. If you explicitly put in a whole bunch of nulls. One of the things is if you explicitly put in a whole bunch of nulls, hopefully you realize you explicitly put in a whole bunch of nulls and you handle it properly. The problem with the new is that you can create a big array and not realize that they're all nulls and then try to do something with it. So a close relative to fill is tabulate. One of the limitations on fill is that this code right here is executed over and over again, and every time it's executed, it doesn't know where it is in the array. So, and of course, it turns out if I were to replace this with list, I would get the exact same type of behavior, but I'd get a list out instead of an array. What if I wanted to make an array where the value in every location was just the index squared? Okay. Well, that's hard to do with fill because this code doesn't know what index it's at. It's going to be the same code for everything, and it doesn't get any additional information. And so that is where tabulate comes in. And I'll go ahead and do the list version here just to demonstrate. But both tabulate and fill work for both lists and arrays. Tabulate is also curried like fill. So you pass the first argument is how many things you want. And then the second argument is not a pass by name argument. It's actually a function. And it's a function that takes a single argument, which is the index of where you are in there. So if I wanted this array to have all of the indices squared, I could simply do that. The advantage of tabulate is that it knows where it is in the array. I could do something like, I guess if I wanted these to be Booleans, I modulo 2 is 0. So this is going to give me back a list, in this case, of Booleans where it's either true or false, and it will be true for all of the even indexes and false for all of the odd indexes. So index 0 is true, 1 is false, 2 is true, 3 is false, 4 is true, etc. So you can do lots of different and interesting things with this. What I want to do at this point is actually write a little bit of code. So from a previous video, we got this temperature data, and we can look at that. And it has almost 24,000 lines of temperature data. This happens to be for San Antonio, Texas, starting back in 1946 and going all the way to 2011. And that's interesting. There is an extra line there. And okay, scrolling back up is not a good idea. So the format of this, we inserted this line at the beginning simply because that was the only way that we knew how to read in the whole file. And at this point, we still haven't fixed that hole in our knowledge. In fact, we don't even really know how to read it from the file. All we know how to do is to enter it into a program using the I/O redirection. So I want to now read this in, and I want to use fill or tabulate in order to do it. So I'm going to make a temps2 here. And it turns out that I don't need to know what index I'm at for this, so as the comment implies, I'm going to use fill here. So I can simply, let's see, val temps equals, let's put these in an array, dot fill of readInt. That will read off this first line here. Now, if all I wanted was just the strings, and in fact that's how we did this last time, was I read in all the lines as strings, and then I used map to transform them and whatnot, I'm actually going to take a different approach here because it's good for you to see different ways of doing this. I'm going to make a function called parse temps and pass it readline. And parse temps is supposed to take a single line as a string. And what do I want it to pass me back? Well, how about I have it pass me back just an array of doubles. Okay. This array of doubles is, I want, for example, the day of the, I don't know, day of the month, the year, and the high temperature. Okay. You could decide to make this read other things, but that's what I'm going to go for here. So parts is equal to line dot split on commas. And then I want to have it so that we're going to give back a new array that has the various parts that I wanted. Parts sub 0 dot 2 double, I'm missing a T, parts sub 1, nope, I do want sub 2, dot 2 double, and then let's see, 0, 1, 2, 3, 4, how about sub 4, part sub 4, dot 2 double, and then 5, 6, 7. Parts sub 7, P-A-R-T-S sub 7 dot 2 double. Now, if you recall, this is actually going to have a minor problem with it if I try to run this. If I push in that file, it compiles, it runs, yeah, and here's our error. You might recall from the last time that we played with this file that there are some places where the temperatures come out as dots. By reading it all in the way that I've chosen to here, instead of doing it as individual lines, and I can't filter that. But what I could do instead is have an if, so that if parts sub 7, which is the one that's causing us problems, is equal to a dot, then I will return an array of 0, 0.0, comma 0, 0.0, comma 0. Well, actually, let's go ahead and, ooh, how about I do it right down here. We'll use the if as an expression nested inside of this. If parts sub 7 equals the dot, then I will return minus 100, which is not a temperature that ever happens in San Antonio, Texas, thankfully. Otherwise, I will return that, and now it reads it in. We could print it, we could do some things with it, but this demonstrates a simple use of fill to read in a whole bunch of stuff. And if you compare this to the code that we wrote previously, where we wrote a recursive function that went through and did stuff for us, fill just makes our life a lot easier for building large arrays, whether they are taken from input with read lines or whether they have random values in them or whatever it is that we want to do with them. So that is it for our discussion of fill and tabulate, and we'll see you again soon.